All right, so you did this practice elevator question, so let's go ahead and take a look at it. So our elevator starts at one height and goes up to another height. So it's going between one place to another place over a period of time. So I'm going to be using average power to go ahead and find this. I'm going to be using the work kinetic energy theorem to find out the work. And so the work is going to be equal to all of that gravitational potential energy because it is moving at that constant speed. So work divided by time, make my substitution. Now, where does the number of people come in? Well, the number of people comes in here in the mass, because the mass is the elevator plus the people. And there's going to be some number of people, I'll call it n, each having a mass of 65 kilograms. So I plug that value in, go ahead, solve for the n value, not the normal force, the n value there, and you should get 28.24 people, but of course, we're going to round that to 28 people. Maybe you could throw a kid in there, I guess, extra. But that's quite a few people to put in an elevator. And that's because they usually design an elevator to hold more than, maybe you could fit 20 people in the elevator. They're not going to want to make it, well, I think the motor can only handle 20. If not, we'll just see what happens. No, you want to over-engineer the heck out of that elevator. So even if someone brings in a pallet of bricks in there, along with a few other people, it doesn't wreck your elevator. If you have ever done this, this is kind of an interesting thing. You'll maybe go to a hotel and a whole bunch of people pile in that elevator. They'll bring all their heavy luggage in there and it'll actually overload the elevator to the point where it'll be like, hey, you put too much in me, get out, less people. It'll actually automatically stop that so it can sense that so it doesn't burn out its engine or, heaven forbid, catastrophically fail. Put a lot extra in that one.